Okay, Assalamualaikum. Hope so you're doing great. So in this lab, which is Introduction to Logic Gate ICs, we introduce Logic Gate ICs, which are the ICs containing obviously logic gates and or not, NAND, NOR, XOR. Uh, Almost every type of gate has a different IC. So let's start. The prerequisite of this lab is you should know the proper working of combination of breadboard. Obviously, you know which how to place an IC and where to place an IC and how to give it proper power and how to measure the output and etc. Similarly, power supply and DMM. Working of LEDs, obviously you will be needing LEDs to show your output, so you should know okay, how many volts is needed for the LED to glow, and obviously you need a resistor in series with LED so that your LED doesn't burn. Similarly, logic digital logic basics, you should know what is a digital logic, like zero, what is zero and what is one. In electronics, zero means 0 volts and one means uh, like on a like bigger scale, one means 5 volts. But it depends on which type of IC you are using. Is it a CMOS or is it working on CMOS logic or TTL logic, which we studied in the first lab. So both the logics, either it is CMOS or TTL logic, has a different criteria of considering which voltage corresponds to 0 and which range of voltage corresponds to 1. So but in lab we will be considering 5 volts as 0 and 0 volts, 5 volts as 1 and 0 volts as 0. But you should remember the difference between CMOS and TTL logic. Then obviously so as it is a electronic circuit, and as I've already told you that digital electronics works mostly on 5 volts, so your overall voltage should not exceed 5 volts whenever you are powering the IC or the whole circuit, until and unless you needs it, like you have connected so many resistors and the overall voltage on the digital on the electronic portion of the circuit drops to around 3 or 4 volts, then obviously you can increase the overall voltage to more than 5 volts, but mostly it is not needed. Then let's move on. So there are different types of gates. For example, there is an AND gate. The truth table of AND gate is drawn here. One, if both the inputs are 1, it gives 1. If any of the inputs is 0, it will give 0, and obviously on both 0 it will give 0 as well. So you will be given multiple ICs, you will see its behavior, you will give it inputs, and then you will see the outputs, and on the basis of that you will predict which IC you are given. Okay, so you will be given multiple ICs. You will uh, you will obviously you will do experiment, and you will make a truth table out of it, and then on the basis of your truth table you will predict that which IC you were given. So IC, coming on IC will look like this. So it is a 14 pin IC. There is a notch here on this notch indicates that the pin numbering is starting from left of it. So if this is a notch, then pin number 1 will be on the left side of it. So this is pin number 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14. Okay, so numbering goes like this. And obviously to use the logic gates you need to power up the IC first. So 7 and 14 pin are used for powering up the IC. 7 is ground and 14 is power. So you need to give 5 volt between 7 and 14 so that you can use the logic gates inside it. So one IC has almost no, exactly 4 gates, until unless it's not a NOT gate. So as you know that one gate needs at least 3 pins, 2 for inputs and 1 for output, and there are total 14 pins. 2 are for powering up the ICs, remaining are 12, and 12 divided by 3 equals 4. So it means there are 4 gates, and all the 4 gates will be of same type. Okay, so if in case one gate is not working, you can use other gate from other 3 pins. Similarly, from right side you can also find 2 gates as well. The arrangement of gates inside it's not permanent. You can check the exact pin out or exact configuration of the gates inside the circuit, inside the IC through Google. For example, you are given an IC with the number 74, like 74LS04. You will search out it on Google with pinout. Okay, you will search it 74LS00 pinout, and then you will find a diagram containing the exact arrangement of gates, and obviously where are the inputs, where are the pins for powering up the IC. So it's always better to search IC number for the exact pinout. Then some basic things about breadboard. Obviously here you will be needing multiple ones and multiple zeros. So if you need to verify this gate for logic 1 1, you will be needing two ones. Okay. Similarly, if the circuit is bigger, if there is a bigger combinational circuit is the one that consists of multiple logic gates, so there will be multiple inputs and can be multiple outputs. So there you will be needing multiple inputs, and for multiple inputs you will be needing multiple fives and multiple zeros, so you will be needing multiple batteries. But here you have, as you know that here on function generator you have only on power supply you have only two power sources, three actually. So this is 5 volt fixed, and these two are variable power supplies, but you will be using only one. This is preferable because it is giving you constant 5 volts, and here you need to fix it first, or arrange it, or like set it to 5 volts first, and then you will use it in your electronic circuit. But if you are using this one, setting the voltage source is not needed because it is already giving you 5 volt. So what you will do is you will take out the connection from here, and you will give connection to this upper two rows that I will be showing you in a while, so that, as you know that this whole row is connected, similarly the second whole row is connected. If you give the 5 volt here and 0 volts here, then this whole row will have 0 potential, and the upper whole row will be on 5 volt potential. So whenever you are needing ones, you will simply take out the 1 or 5 volt from the upper row through the jumper wires, and similarly whenever you will be needing the 0 volts, you will take out the connection from the bottom row of this row. So this row is connected from here to here, and this line is indicating the connections. Where this line breaks, where this line, red line and blue line breaks, there the continuity of the rows also break. So this thing I will show you a bit later because I will be performing the experiment. These are the required materials, required ICs. You need IC, jumper wire, resistor, and LED to show the output, breadboard, power supply, and power cable. So let's perform the experiment. Okay, so this is the IC that I was talking about. It is a 14-pin IC, and this is the notch. This is the notch, and numbering is starting from here. The 7 pins are here and 7 pins are here. Pin number 7 is ground, and pin number 14 is 5 volts. So you need to give this power supplies to power up this uh, gates. Obviously gates also consist of transistors and diode. There is a complete circuit we studied in, I guess, lab number 4, in which we made AND gate with the help of diode. Similarly, you can make diode with transistors as well. You can, by using transistor as a switch. So inside it there is a circuit obviously, and you need to power up that circuit first to use these gates. And okay, this is the LED, and many people are still confused about the polarity of LED. So you can check obviously by the legs, okay, which one is positive and which one is negative. But if in case legs are cut equally, how will you check the polarity? It's very simple. So it is probably all LEDs are usually transparent. So when these are transparent, you can see inside it the one region is a bit bigger and the other region is a bit smaller. The bigger region is negative and the smaller region is positive. As electronic circuits in the remaining DLD portion are a lot bigger than the EDC portion. So it's recommended to check every component before using it in the circuit. So how can you check if your LED is working properly or not? By simply giving it 1.5 or 2 volts. So let's give 1.5 volts. So see, I have given, you can give 1.5 to 2 volts. So I have given 2 volts and LED is glowing. Positive is connected with the same portion I have told you earlier, and negative is connected here, and it is glowing, so it is working properly. And as the output in the electronic circuit is of 5 volts, so 5 volt your LED will get burned. So you need a resistor in series with it. So to save your LED from getting burned. Okay, so this is the breadboard and I'm fixing the IC here first. So this is the IC and I'm placing it here. You need to be very careful while fixing and obviously defixing or removing the IC from the breadboard, because its pins get damaged easily. So while removing it, good practice is to use a ball pen or any pointy thing, and you will give slight push so that it is easily removed. Now I will place it again. So I have placed the LED. Now I need to give it power. On which position? Pin number 7 and pin number 14. Okay, so first step, I have given this whole row 5 volts so that I can pick 5 and 0 whenever I want it in the circuit. So see, I have given this whole row 5 volt with the help of this power supply and using the fixed power supply because I need 5 volts. And then for powering up the IC, I have simply taken out the voltage from here. So 0 volts connected at pin number 7 and 14 volts connected at pin number 14. And now I have fixed LED in series with the resistor on which I will be showing you the output, or you will be showing me the output while performing the experiment. So I have connected almost 100 100 ohms resistor in series with the LED, and as you see that the negative of the negative of the LED is ground. As I've said, pin number 7 is already grounded, so I have taken advantage of it for providing the ground to this small circuit. So this node should be connected with the output, and then the circuit will complete and LED will glow if the output is 1, and it will not glow if the output is 0. Now I will be using its first 3 pins, these 3, for verifying the gate. First 2 will be inputs and the third one will be the output that will be connected with this LED with the help of obviously this whole row, because this whole row is connected. So you will simply need to connect this node with this row. So yes, this pin number 3 and this whole row or column. But okay, so this circuit. So now one thing is remaining, that is input. So input, for example, you want to check it on 1 1. So what you will do is you will give it's both the inputs 5 volts, obviously by taking the 5 volts from this whole row, because this upper whole row, the red one, is on 5 volts and the lower whole row, the blue one, is on 0 volt. So first I'm trying it out on uh, 1 1. So what I will do is I will pick 1 from here and I will give it here. So I've given 1 here, and similarly I need to give 1 to second input as well. Okay, now let's turn on the power supply. Okay, so now I have turned on the power supply, and as you can see from it, I have given given it 1 0, 1 from the upper row and 0 from the lower row to its both the inputs. See, first input is this one, and second input is this one, and I have given it 5 volt and 0 volt, 1 and 0, and output is output can be visualized by this LED. So the LED is not glowing on 1 and 0. Now switch it to 0 1. So switch the positions so that you can give it 0 1. So on 0 1 still LED is not glowing. Now 0 0, still not glowing. Now so probably you have already guessed the gate. It's an AND gate. It will only give 1 on 1 1. So I have given 1 1 on both the inputs and LED begin to glow. Okay, it's always a good practice to give a pull down or connect a pull down resistance with the input. Pull down resistor is the resistor connected with the pin and the ground. So for example, if I give this blue row ground, so what I will do is I will simply take a resistor and connect it between the pin and ground. So it is called pull down resistance. If you are connecting the resistor with the pin and 5 volt or high volt, then it is called pull up resistor. Currently it is pull down resistor. Similarly, you need another resistor with the second input. See, so it is done that so as if no input is given to the gate, it should be on ground. See, you have not given it any input. So if you are not giving any input, so it is on ground at like without input position. This is called pull down resistor. So if you want that, if you are not giving the input and your input pin should be on high voltage or 5 volts, then you need a pull up resistor. So as if no input or no input voltage is coming on the input, 5 volt should be coming on the input through this resistor, which in this case is 0 volt through this resistor because it is a pull down resistor. So it is a good practice while making the combinational circuits or any electronic or any digital electronic circuit or whenever you are using gate. See, so it's technically 0 0 0 0. LED is off. Now it will only turn on 1. This is very low voltage. It should glow completely. See, so here the experiment. So obviously in this lab you will be given multiple ICs and you need to see that which IC is representing which gate, and obviously you will be making the report on that. And for the reports, you will be following this pattern: objectives, theoretical background, working of circuit 1, circuit 2, circuit 3, of all the circuits that you will be making in one lab. Then simulation, you will be making the same circuit on Proteus. Again, circuit 1, circuit 2, circuit 3 on Proteus. Then truth tables, obviously it is a digital electronic circuit, so there will be truth tables, you need to include that. And obviously at the last, you need conclusion. So this pattern will be followed for the remaining DLD labs. See you in the lab.